Welcome to Geometry Pre-AP, the best class in the world. Today we're going to learn about similarity with perimeter and area and geometric figures, and we're going to learn about Theorem 11.7 in our lesson today. So as we go in here, we got a little information we want to go over with so we can understand some of the basics. So it says use the similar figures in box A to find the answers for the box B, C, and D. So if we look at figure A, we have two rectangles. These two rectangles are similar. We have the dimensions of 2 and 3 on the red one and 6 and 9 on the blue one. It says, what is the ratio for the sides of the blue to the red? So we're putting blue to red. And so for my blue figure, that's a 6. And for my red figure, that's a 2. And so when I reduce these, I get 3 to 1. So my blue to red ratio is 3 to 1. And it says, what is the ratio in part C here for the perimeters of the blue to the red? So the blue's perimeter is 6 plus 9 plus 6 plus 9. And so that's 15 plus 15, which is 30. The red's perimeter is 2 plus 3 plus 2 plus 3. So that perimeter is 10. So if I do the ratio of blue to red again, I get 30 over 10, which reduces to 3 over 1. Remember that all ratios should be reduced. Next, we got to do the area. The area of the blue would be 9 times 6, which is 54. And the area for the red will be 2 times 3, which is 6. Now when I compare the areas, this time of blue to red, I get 54 over 6. And that's my blue to red ratio, which reduces to 9 over 1. What's special about this is actually there's a connection between all three of these here. You don't see it as easy here, but when I take this ratio of 1 over 9 and rewrite that as 1 to the second power over 3 to the second power, I can see that the ratio for the areas of the figure is squared compared to the ratio of the perimeter and the ratio of the sides. We did the perimeter ratios back in the first semester. Now we're bringing in the area ratios. That's going to be the important part for today's lesson. So we have Theorem 11.7, which says if two polygons are similar with the lengths of their corresponding sides being A to B, then the ratio for their areas is A squared to B squared. We learned in first semester about the ratios for the side lengths was A to B, and that the perimeters is also A to B. But now the area is A squared to B squared. And this is where the changes occur and where all the difficult work comes in at, is which one to use, when, and where. It all depends on what the question is asking. So if we go here to this page, I'm going to fill in a few of these, and then you're going to fill in the others. So if the ratio for the sides for two figures is 6 to 11, the ratio for the perimeters would also be 6 to 11. It's the same, and those ratios should be reduced always. But the ratio is going to be A squared to B squared, so it'll be 36 to 121, and that's reduced. So if we have the ratio of the perimeters and we want to do the ratio of the areas, I cannot do 20 to 36. That's not right, because that ratio is not reduced. If I actually reduce that ratio, I would get 5 to 9. They're both divisible by 4. So this one actually should have been changed to 5 to 9 once you wrote the ratio. Now if I go to the area one, that'll be 25 to 81. We square that ratio for the perimeters or for the sides. Now this one we have the perimeter for the ratio for the area, and I want the ratio for the perimeter and the sides. If I square to go from this ratio to this ratio, then to undo it, I reverse that process. And so if that's 49 to 16, it would be 7 to 4, and this one would be 7 to 4, because those two ratios are the same. So for your notes, I want you to do these last three and fill those in. You can pause the video now, do those three, and then start the video when you're ready to go again. All right, so now we go to our first actual real problem. Get in the habit of writing these problems out correctly. It'll help you when you start working the processes. So the first thing I look here is I want to find the value of the area for this figure. This is my unknown information that I want. So we start off with a ratio for the sides. So I like to write sides, and I can write the ratio. I've got red and I've got blue, so I'm going to do red over blue, which is 7 to 9. Now the side ratio is also equal to the perimeter ratio. But I'm not working with perimeter here. Now there is an area ratio. Remember we did that in the last slide before this. So the area ratio would be 7 squared over 9 squared, which is also equal to 49 over 81. So my question's asking me to find an area. So since this question says find the area, I want to use the area ratio. So I write that 49 over 81. Remember, I'm doing red to blue equals the red area. I don't know. So we'll take that and we'll make that a variable. The blue area is 210. And then we cross multiply and solve. So I get 81x equals 49 times 210 divided by 81 divided by 81. Simplify that down. That's 3,430 all over 27. And of course, that'd be inches squared. Remember, the units are important. All right, so now we go on to the next page. This is one that I want you to do. So take a minute to solve this one. It's got the star by it. Pause the video, work the problem, and then turn the video back on when you're ready to check your answer. All right, when you're done with this problem, you should get an area is equal to 242 centimeters squared. Make sure you have the work to go with that. Show your ratios, show your proportions. All right, here's another question. This one says use the given areas to find the value for x, y. So this is my unknown information here. We'll just call that x to start here. So let's start work with our ratios. We have the areas of, we'll do blue to red, which is 7 over 28. But this is areas, and that ratio can be reduced down to 1 over 4. If this is the area ratio and I want to find a side, I need the side ratio. And so the side ratio is equal to the square root of the area ratio, which is just 1/2. Remember the chart that we filled out. So because I'm finding a side, I want to use this ratio. And so when I work this problem, I got 1 over 2. I'm still doing blue over red equals, my blue number is 4, my red number is unknown for x. And so then I get x is equal to 8. And of course we need our units, just centimeters. This right here is the most important part of the problem, getting the ratios to the right thing. Okay, so here's a question for you to do. Pause the video. Make sure you simplify those ratios when you're getting those ratios all figured out before you work the problem. So pause now, then come back when you're ready to check your answer. All right, so now that you're done, you should have your answer. XY equals, we got 15 inches. So make sure you have all your work with your ratios and all that there and show your proportions so you can solve that problem. All right, this is a little more difficult problem. We have a couple of these problems to do, and I'll have one for you to practice after each one. So on this question here, we're going to first look at what we have. We're given the areas. They always give us some sort of ratio where we can develop. And so we have the ratio here. We got 18 over 72. Okay. And so 18 over 72 reduces to 1 over 4. But what they're asking us to find is the value for x. And since it's the side, I need the side ratio. And the side ratio is going to be the square root of the 1/4, which is just 1/2. And then I set up a proportion. 1 over 2 equals my side for the one side, which is the x plus 1, over the side for the other one, which is going to be 3x. Now that I got a proportion, I just cross multiply and solve. 3x equals 2x plus 2 minus 2x minus 2x. X is equal to 2. And there's our value for x that makes these two figures similar. All right, we don't have a unit in this case, we just have a value of x. So on this problem here, take the time, do this problem. Remember, all the work comes at the ratio part. When you're done, turn the video back on to check your answer. All right, since you turned the video back on, your answer here for x should be x is equal to 5. So these are one of the two ways. These questions will show up possibly on the test, so make sure you can do this topic. We also have another version of this question. This one's a little more difficult. This one's going to take some space and some room. And so when you do yours, you'll have to give yourself some space and room. So we have perimeters this time, not given areas. So the perimeter ratio for this one is 21 over 10.5, but that reduces. That actually reduces to 2 over 1. Now the information they're giving us this time is side information. But remember that the perimeter and the side ratio are the same. So there's no difference in those two. But I need that ratio to solve this problem. So I'm going to do 2 over 1 equals, and I'm going to go pick a side, 2x minus 2. And the corresponding side that goes with this one is the 3y minus 9. Oh boy. I've got two variables. But when I have two variables, that usually means I have some sort of system of equations. So I get 2x minus 2 equals 6x minus 18. I'm going to get this in standard form, which means get all the variables on one side and all the numbers on another. And there's my first equation. I got to do this problem again, because I got another set of sides. So I got x plus 4 here, and the y matches with that over y. Cross multiply. X plus 4 equals 2y. I want to get it all on one side, so x minus 2y equals 4. Now I've got a system. I got x's and I got y's. I think it would be easiest if I just take this equation right here and multiply this one by -2 so that these variables will be able to eliminate. When I do that, I get -2x plus 4y equals -8. So I'm going to rewrite those up here. 2x minus 6y equals -16. -2x plus 4y equals -8. Remember that these eliminate, that's why this is called elimination. -2y equals -24. Oh, I just found one of my errors while I was working back here. We multiplied this -2 times these things, and this becomes this number when it moved over here was a -4, so really that's a +8. So that's a +8. I'm glad I caught my error before we got too far into this. And so then this becomes a -16, and so then y is equal to a positive, oops, that's not 16 there, that's a +8. So this becomes a -8 divided by that gives me a +4. So there's my 4 value. Remember that when you're dealing with systems, it's so easy to lose a symbol. All right, so now I need to go find my y value. Well, I got my y, I need to find my, so x plus 4 is equal to 2y, so x plus 4 equals 2 times 4, so x plus 4 equals 8, minus 4, minus 4, so x is equal to 4. So remember to write your answer always as an order pair, 4, comma 4. And there's my answer for this system of equations. Be careful when you're working these problems. You can lose symbols so easy. So give yourself the room to work and line your stuff up so you can watch it. You saw me just do it earlier. I lost the symbol when I moved this 4 from this side to this side. It got lost. So that's something you need to look for. So here's a problem. Pause the video, work this problem out, and when you're ready to check your answer, start the video back up again. Okay, so if you're checking this answer, you should have gotten 8, 3. There's going to be a lot of work there, so make sure you give yourself the room to work. That's the end of the lesson. Make sure you bring these notes in for class when you come into class, and we will see you on Friday.